Hello everyone, my name is Tina Harpawat. Today we will start a new topic named number system and conversion. ये एक ऐसा टॉपिक है जिससे कोई ना कोई क्वेश्चन बनता ही है। अगर आप कोई भी कॉम्पिटिटिव एग्जाम की प्रिपरेशन कर रहे हैं तो ये एक टॉपिक है जिससे क्वेश्चन बनेगा। Like if you are preparing for any government exam, it can be a computer instructor or informatic assistant, something like that. तो अगर easiest question on the computer science based, if someone ask me कि ऐसा एक टॉपिक तैयार करा दो जिससे मेरा कल पेपर और एक क्वेश्चन तो आना ही है, तो आई वुड सजेस्ट कि he or she should prepare for the number system. So I would start this topic here. Number system is something like that. For convenience people use other bases. Basically, what is this thing that usually all the numbers, like if two humans are talking, they can't talk in 0101, but we all know that computer understand the language binary. Binary means all the signals, all the instructions provided to the computer or any digital device is in the 01 form. That's why we say that it's a digital device. So you can see in this diagram, I would like to describe this, that if you can see all the electronic devices here, all the working of this in the 01 format. But when two humans are talking, they can't understand this. They can't understand the binary format. So there is a need to convert this language 001 0101 into some format which is understandable by human. So that's why it is known as the conversion, that machine language or machine understandable language to the some human readable language. I would explain in further slides that what is this conversion, what is this binary, and what is this binary to digital. So basically there are four kinds of number system, basic. Other than this also possible, but yeah, four kinds of number system is here: binary, decimal, octal, and hexadecimal. So first category we are going to explore is binary number system. In the binary number system, the thing is all the things are in the base 2. Base 2 means it will have two symbols, and the symbols will be either 0 or 1. Means all the data, all the signals, all the numbers will be written in the two with the help of two symbols only. It can be like when you have to perform addition, there will be some machine understandable language that it is giving 001 for addition. It's just an example. It can be something like that all the commands are written in the 01 format. So this is known as the binary number system. In the binary number system, if I write some number like 1010, this 1010 is actually, when I convert it in decimal, that is equivalent to 10. And now how to remember? If someone is not taking the help of another number system, then how can someone can remember that 1010 is 10 and 1011? So when the number is very big, it is very difficult to remember. And the thing is, when some zero is replaced by one and when some one is replaced by zero, it is very difficult to understand, or sorry, difficult to identify the error. So binary number system has some limitation, that for machine it's okay, but for human it is not convenient to do all the operation with the help of binary number system. The second kind of number system is decimal number system, and it is a number system which we usually use, like humans use. Like if some I say that I have borrow someone 1,000 rupees, or I say कि मैंने किसी को 500 रुपए उधार दिए, तो all the conversation what we are having, all the exchange of money we are having in the format of decimal number system. So for this number system, the base is 10, and symbols used are 0 to 9 numbers. So 0 to 9, when I start with 0 and when I move towards 9, so total symbols are 10. Example can be anything: 999, 212. So all these numbers are in the base 10 format. The third kind of number system is octal number system. As the number name is itself indicating that it will take the help of base 8, and the symbols used are total 8 symbol starting from 0, so total 7, 0 to 7 numbers. For example, it can be 121, 777, anything. Okay, but not number greater than 8. So I will say that 778 is not in octal number system. Keep in mind. The last number system here we are describing is hexadecimal number system. It is somehow different from the remaining three, that it is having base 16, that's fine. And the thing is, it will have numbers as well as it will have some symbols, or I will say symbols or alphabets. So it is having 0 to 9 numbers, fine, but it is also having some symbols, and that alphabets, I would say A to F. So what it mean A to F, that if you have to write 0 to 9 number, you can take the help of numbers. But when I have to write 10, how I will write 10? I will write the 10 with the help of A alphabet. Similarly, 11 is written in the B format, capital B is 11, and so on. So last F is for 15. So 0 to 15 it is also covering, but the thing is the 15 or 13 is written with the alphabet. So in this way, the 13 is itself D and 14 is E. So this is how the hexadecimal number system symbols are. So if someone asks me what is the example of hexadecimal, so you can say 1AF. If I write this number and it is in the base 16, so it's a hexadecimal number system example. Okay. Now, till now we have seen the number system types. Now, the next thing we are going to cover is that how to convert one number system to other. Okay, how to convert one number system to other. So for example, I'm having so next slide is for conversion. You have to convert one number system to other. So this is very important diagram. I would suggest that if someone is going to study this for first time, like which is non-computer based, like someone is not having non-computer background, so I think it should start with this diagram, that this diagram should be in your mind whenever you are performing some conversion. So how this diagram works, whenever you draw this diagram, you keep in mind that you can how this diagram should be studied, that you can convert decimal to octal, octal to decimal, decimal to hexa, hexa to decimal, hexa to binary, binary to hexa, binary to octal, and octal to binary. All these conversion are directly possible, but the thing is that decimal to binary and binary to sorry, this someone asked me that how uh, one second, I have not drawn one thing here. So one more conversion is here. If this is also here, that decimal to binary and binary to decimal is also there. But the one thing you have to keep in mind, that octal to hexadecimal is not having any direct connection. So whenever someone asks me that convert this octal number system to hexa, what I have to do, I have to take one path. Either I can take octal to binary or binary to hexa, or I can take octal to decimal and decimal to hexa. So this depends, but direct conversion is not possible. Fine. So keep in mind that this was I forward. So you have to make this connection also, decimal to binary and binary to decimal. Okay. Now one more thing to keep in mind is whenever you are moving down in this diagram, decimal to down, decimal to anything we will do divide, anything to decimal we will do multiply. Keep in mind, decimal to anything is divide, anything to decimal is multiply. What is mean, I would tell you further. So let's move to the next slide. First I have to rub this, one second. Okay, now I'm having a number system decimal and I have to convert this into binary. Now decimal to down, decimal to anything is divide. Keep in mind, right? So now what I have to do, I have a number 25 which is given in a decimal number system. Now what I have to do, I have to find out what its equivalent binary value. Okay, so I would start, and I know that I have to perform a division. I would divide it with the base 2 in which I have to convert. So when I divide 25 by 2, it will be giving me 12 as quotient and 1 as remainder. Again, I will divide 2. So 6. 6 it will 6 time it will be divided and 0 remainder. Again, I will divide 3 time it will be divided with a 0 remainder. Again, 1 time it will be divided with 1 remainder. Again, 0 time it will be divided and 1 remainder. Okay, so this division you have performed. If you want, you can just rewind it and see it again how I perform this division. And now what you have to do, you have to write this number in reverse format. How? So it will be written that bottom to up. So the result is 11001 and it is in a binary. So what we have done, just a quick revision. I was given with a number or decimal number 25. What I have to do, I have to perform a binary conversion. To convert in binary, what I have done, I have divided it with 2. So whenever I'm dividing it with 2, I'm just writing here the remainder part. Soon I have found that a number is lasted and I'm having the 10011 as remainder. Now what I have to do, I have to write it in the reverse order. So that will be giving me the result. So I am having the result 11001. Okay. So that will be your answer. You can see here again. Next. So we have convert a number which is given in 20 decimal, that is 25, and I have written its equivalent binary number. Next is decimal to octal. So we are covering the part decimal to anything. So decimal to binary we have seen in the last slide. Now we are seeing that how to convert a decimal number in octal. Again the division format, but here the division will be by the number 8. Okay. So 8 is a 24. Right? Remainder is 1. Oh, sorry. 8 3s are 24 and I'm having the remainder 1. Again, I will divide. I will divide and I will see. Sorry, I've written it wrong way. Here I have to write quotient. It's 3s are 24. It's a remainder here. Again, I will divide it with 8. So it will be divided by 0. Means 0 times it will be divided and it will give me the remainder 3. Now the same process I have to follow. I have to write in the reverse order. So it will be giving me the number 31. So 25 in decimal is equivalent to 31. Okay. Fine. Next is decimal to hexa. First we have done decimal to binary, decimal to octal, and the third thing we are doing is decimal to hexa. So I think you should try it by yourself, but pause the video, try it by yourself, and then again come back here. So I will divide 16, 25 here, and 16 ones are 16, 16 twos are 32. Now it will left me with the 9 remainder. Again, I have to divide. 0 times it will be divided and 1 is the remainder. Reverse I will write and it will be giving me the answer 19 in the hexa. Let's see. Yeah. So it is having 19. So till now what we have seen that how the conversion is being done, how we are doing the conversion. Give me a second. So decimal to binary, decimal to octal, and decimal to hexa we have done. The next thing we are going to do is reverse of this. So keep in mind the diagram. And now what we are doing, anything to decimal. So we are moving in the upward direction. In the previous diagram, if you will see, we are moving in the upward direction. In the upward direction, what we have to do? We have to do the multiplication. Okay, so let's start. Anything to decimal. So binary, first one is binary to decimal. Now binary to decimal means I have to perform the multiply. And what number I have given? This one. What I will do? I will start with the leftmost number, this one, and 2 to the power 0, multiply it with the given number. Okay. Now next is I will increase the power by 1, left to right. Now next one will be 2's power 1 with the 0. Next one will be 2's power 2 for the second 0 into again a 0. Although I know that multiply with 0 will give 0, but yeah, for the start I will write it all. 2's power 3 into 1 and 2's power 4 into 1. So all the terms which are being multiplied with 0 will be giving us a 0. So these two terms are 0. Anything's power 0 is 1. So 1 into 1 is 1. This is 0. This is 0. 2's power 3 is 8. 2's power 4 is 16. Now I will add up this. 16 plus 8 is 24 plus 0 plus 0 plus 1, that is 25. Although we know we have already done this 25 to conversion of this. But yeah, what we have done, now see it carefully again, that you are having a number in binary, you are required, you are asked to convert, or you are asked to give its decimal equivalent. What you have done, you started with the leftmost, and what you have done, you have just write the base with the power. So you started leftmost, 2's power 0 with the 1. Now you know 2's power 1 will be multiplied with 0, so skip this. 2's power 2 will be multiplied with 0, skip this also. 2's power 3, yeah, 2's power 3 is multiplying with 1, and 2's power 4 is multiplying with 1. So multiply with 1 is ultimately a only power. So 2's power 4, 16, 2's power 3 is 8, and 2's power 0 is 1. So 16 plus 8 is 24 plus 1, 25. That's how you got the number. Okay. Now first binary to decimal I have done. Next I have to do binary to octal. Okay. Binary to octal, how to do it? I am given with a number. Now what I will see, in my given diagram, the system was this: decimal, binary, octal, and hexa. Now this decimal to binary to octal I have to do. This conversion I am doing. Okay. So binary to octal I can convert. There are two ways. First, what you can do, you can make the pair of 3 3, or I would binary to octal. For this, we can take the help of that. I can convert a number. Uh, First, I am given with a binary number, so I would convert that number in decimal. In the previous step, I have already done that. That binary to decimal. So this was equivalent to 25. So it is equivalent to 2510. Now decimal, I know how to convert the decimal to octal. So decimal to anything is divide. And when you convert this, you will get a 31. So basically what I have done, I want this number octal to binary, binary to octal. First step, what I have done is that you convert this binary given number into the decimal. Binary to decimal, we have just done that, how to convert a number to binary to decimal. After converting a number, in the previous slide only we have done, your intermediate result is ready, that is 25, and then you convert 25, which is in base 10, to the octal. Okay, so that's how you can make a conversion. The second, or I will say the shortcut method, is something like that. When someone asks you octal, octal means you have to make the grouping of 3 bits. So number given is 11001. I will make the grouping of 3. So this is a 3 and this is only 2. So I can append the number 0 here. Now what will happen? 011 and 001. Now this binary number is equivalent to 1. This binary number equal to 3. So I can do, and this is a very shortcut method. So if you are a very beginner, I would suggest you do in the conventional way, that you first convert that number in decimal and decimal to octal. If you are you are doing it in very regular basis, so group it in the 3 bits, write it binary bits, your decimal equivalent, and you will get the result. Both are possible. Okay. Similarly, binary to hexa. Again, recall the diagram: decimal, binary, octal, hexa. Same thing I would say, binary to hexa. Two ways are there. Write binary to decimal. So I know that it's a 25. Then 25 to hexa. Means you are doing in this way: binary to decimal, decimal to hexa. That's also possible. A shortcut method I would like to tell you here. When you are grouping 3 bits, that in octal, in hexa you have to group 4 bits. So you are having a number 11001, group it in 4 bits. this is 4 bit. It is only left with 1. You can append 3 zeros here. Now this is a group of again 4 bits. Now what you will do? 1001 is in binary 2. If I want to write its decimal 9, it's a 1. So it's hexa. Very short. What you have done, just group it in 4 bits and write it binary decimal equivalent. 1001 is 9, 001 is 1. So this is the way. If you are beginner, I would suggest that start with binary to decimal conversion, decimal to hexa. So keep in mind the diagram, and in any way you can do it. Okay. So that was all about the conversion. Some things are left, like you have converted decimal to binary to decimal. But yeah, the next thing we are left here is how to convert a octal to decimal. So octal to decimal is still left. So I would clear it here. Octal to decimal. Octal number is given and I have to write a decimal equivalent. So here octal number is 31 and I have to write its decimal equivalent. Now anything to decimal, again recall that anything to decimal is multiply, right? So 31 I am having as an octal number. What I would do, multiply with what? 8. So leftmost I would start 8 to the power 0, multiply with leftmost bit 1, plus 8 to the power 1, multiply with second bit. So it's 3. Anything's power 0 is 1. So it will be giving me 1. 8 into 3 is 24. Add it. 24 plus 1 is 25. So yeah, this is my answer. When I'm given with the octal number 31 and I have to convert it into decimal. So and keep in mind that anything to decimal is multiply with the base. Okay. Now in the same way, one more thing is left. Hexa to decimal. Again, anything to decimal. The number we are discussing is again 19, or I would say that take a number which is a bit difficult, like 1a. Keep in mind that hexa is number plus symbols. This hexadecimal number given to me, and I have been asked that what is a decimal equivalent. So hexa to decimal, anything to decimal is multiply. Multiply with power, 16's power 0 with a. 16's power 0 with a plus 16's power 1 with 1. Anything's power 0 is 1. So 1 into a is ultimately a. A is nothing but 10. We know this. 16's power 1 is 16. Right? Now 16 plus a. A is 10. So 16 plus a is your 16 plus a is your 26. So the 26 is correct answer. So when someone has written 1a in hexa, how can you write it decimal equivalent? This is your decimal equivalent. Now, if you want to recheck it, how can you recheck? You convert this hexadecimal to binary, then binary to decimal. In any way, you can recheck. If you are having plenty of time, you can recheck this also. Okay, so this is how we are performing the conversion. Now in the next part, what I will cover the fractional number conversion. Like if I'm having a decimal number, then how to convert a binary to decimal, decimal to binary, and so on. So I think you like this, and please go through this. If you have any doubt, you can write in the comment. Thank you.